Okay, hi, Miss Knight. Today we're going to be going over distance versus displacement, and another name for distance is the definite integral of velocity. And what you're going to get from that is first we're going to find distance. So distance is the full path. You got to go all the way through all of this. While displacement is a straight line to the point. You want to go there as fast as you can with displacement. So for distance, first we're going to find 0 from 2, which I had found this in the past video, but I had messed up. So I'm just going to show you the work I had already done. So 0 to 2, integral t squared minus 4, because that's the formula for velocity in this problem. And you go through taking the integral, you plug in your 2, and you're going to get negative 5 over 3. So from 0 to 2, hi, cat, you cannot be in the video. You're going to get a negative direction from 0 to 2. But if you go 2 to 5, checks, stop. You're going to take the integral 2 to 5 t squared minus 4. And you're going to get 1 over 3 t 3 minus 4 t 2 to 5. We already know what plugging in 2 gives you. So, sorry, that's 5. So it's going to go 1 over 3 minus 8 over 3. This is going to give you 125 over 3 minus 20. And then 1 divided by 3 is 41 and 2 over 3. So it's going to go 21 and 2 over 3 minus 8 over 3, because you subtracted 20. And if you do the 21 over 2 minus 3 minus 8 over 3, that's going to get you 39. So the distance between 2 and 5 is 39, which is also a positive. From 2 to 5. And to find the displacement, we're going to use the same equation. But displacement, all we have to do is we have to do basically Pythagorean's theorem. So we know it's going from, say, we're going to make triangles for both these. It's going from 0 to 2. So that, the bottom is going to be 2. Now we need to know how far up and down this goes. And that you get from plugging in 2. And so when you plug in 2 to this equation, you're just going to get 0. So the displacement from 0 to 2 equals 0. Because if you do Pythagorean's theorem, you do 2 squared plus 0 squared wait, never mind. It is not 0. I lied. 2 squared plus 0 squared. Sorry, I'm creating this problem by myself. It's going to be a straight line. So this is also going to equal 2. This is not a triangle. Ignore that. This is just going to be a straight line, because as you can see here, when you plug in 2, it is still 0, so it does not go up and down. What likely happened is, as it went negative, it went down. So this would be the distance. It's just negative, but it ends up hitting the same point, and that's why the displacement is 0. No, the displacement is a line, which is 4. Ignore every time I say 0. That's wrong. And when you try to do this from 2 to 5, you can tell the difference between 5 and 2 is 3. So the bottom of my, so it's a triangle, hopefully it's a triangle this time, is 3. And then when you plug in, because this would technically be the coordinate 0.5, we plug in 5 into the equation, you're going to get 25 minus 4, which is 21 up. So 3 by 21 triangle-ish, quotation marks. 21 here. And if you do 3 squared plus 21 squared equals c squared, which is Pythagorean's theorem. Oh yeah, you can still see that. What you're gonna do, you're gonna put that in your calculator because no one wants to calculate 21 squared. That's gonna give you 450 equals c squared, and you square root that. And you're gonna get 21.21 equals c, and that's gonna be the displacement for the second one, as that one likely had a curve like that, but the direct distance, which is the displacement, is 21.21. You can use this equation when you're like driving. A lot of problems with this while I'm driving, hiking. The picture I put on my slideshow is hiking, and you're gonna see this problem used in like real life problems and word problems. You can also use it in real life for finding distances and how you can get there the fastest. Thank you for watching. Sorry about my cat.